My name is Adrian Edge. I'm with Innotech Windows, and I'm representing Fen Canada today as the Pacific Chapter Chair. So we're doing a live event really based on what we've been calling the NFRC size specific calculator. So there's a fairly long conversation in the background, which we're going to get into in this presentation. But before we get into any of that, well, it worked here a second ago. You got to be closer. There we go. Okay. Just wanted to give a big thanks to our host, our sponsor, and our speaker. So Fen Canada and RDH, thank you both for hosting this event and making sure that this is comfortable, and love the space. Thank you. And Fen Canada provided lunch and tech support and dongles and all the things that are necessary to make something like this happen. Thank you very much to Sherwin-Williams. They've been funding, sponsoring all of our events for Fen Canada, which has been great. It makes this a free event that we can offer to the public. And thank you very much from Layton Consulting for Jomo helping put this all together and really spearheading a lot of this conversation in the background. It's personally, I feel like this is a big step for our industry, is to start looking at this particular subject and kind of the sphere of accuracy when we start getting into net zero. That's a whole deep well of conversations. So thank you.
Awesome. Yeah, perfect. We're good. Awesome. So like you see when you hear in the map, we have offices from the East Coast to the West Coast. And so we are a collection of seasoned engineers, architects, and scientists, technologists, project managers, in construction. Oh, this thing loves to advance. And construction experts that bring rigor to the design and construction process. We are proud to be trusted partners of our clients in our work with the property managers, stratas, contractors, developers, building owners, and so forth. Our capabilities range from historic preservation, deep energy retrofits, building enclosure engineering, structural engineering, capital plan reports, depreciation reports, energy and sustainability analysis, construction litigation, research and forensics, facade engineering, facade structural services. So we believe in innovation and expertise at RDH. Construction project management, for example, we utilize a team of experienced construction managers and site superintendents to ensure the smooth implementation of a construction project. For deep energy retrofit projects, we can use our passive design approach to create energy efficient buildings, and a well installation, all airtight enclosure reduces the need for heating and cooling and improves occupant comfort. We are regularly called upon to assess and clearly explain building enclosure and other building science failures. The high level of building science, expertise at RDH leads to many requests for us to provide expert investigative reports and testimony as part of the litigation support role. We collaborate with you on renew specific building components or conduct our targeted or full building rehabilitation and upgrade projects. We have the building science and construction management expertise to lead you each step of the way. We help our clients make sound decisions regarding all aspects of the building enclosure. We consider performance issues beyond heat, air, and moisture, such as structure, cost, impact, and construction schedule, and availability of materials. This thing does not like me. Okay, so we're moving on. We help achieve energy and sustainable objectives. We work with all kinds of building types, energy codes, including the most aspirational performance targets. So our involvement with governments to develop energy and carbon design requirements and with utilities to assess and design energy saving programs means that we bring detailed knowledge of current and future performance mandates to our projects. We do a lot of whole building energy design, from early stage design modeling to optimize using costs in concert with building enclosure design, reduce risk of non-compliance and or changes, and manage design efforts and construction costs by establishing energy performance targets. RDH is dedicated lab spaces, which allow the ability to test and vet new materials and systems, as well as develop building-specific systems. RDH works with many of the major material manufacturers. Staff at RDH are equipped with advanced training, and we have good ties with many of the universities, including teaching at several of them. Our staff is explore new ideas from first principles and tests as required. Whether the facade is built with cladding, curtain wall, glass, stone, masonry, or other materials, RDH offers consulting services and technical advice that makes architectural ideas and concepts come to life. We can offer the most value by getting involved with at the earliest stages of a project and help architects turn the concept into executable plans. So we do this by focusing on aspects such as design, certification, fabrication, and installation through every phase of the project. We work directly with lasers and manufacturers to undertake a structural design of the fenestration system. We prepare structural engineering and thermal calculations, as well as review shop drawings to ensure compliance with building codes, design documents, and specifications. We also help in the development of current codes and are authored on many of the technical guidelines and documents like you see here. Thank you for your time. Really appreciate this opportunity to introduce RDH to you. And if you have any project needs, connect with our team at any time and scan the QR code. Thanks.
Yeah. All right. So if it's all right, since we're kind of an intimate group, I thought we'd go ahead and do quick introductions for everyone so we kind of know who's in the room. Warren, I'm going to start with you since you're at the very back. So I'm going to get started with a little bit of background on how we found ourselves at this conversation, because it's been it's been AGM 2022 when we got started with this conversation. So at Fen Canada, we had our AGM, and Dave Goldsmith, who, again, I'm not going to inflate his ego here since he's gone, but he brought it to our attention that there was an issue. So the issue was in Vancouver. We'll kind of get into it, but there's this line right here that says, in case of conflict between provisions of the NECD and City of Vancouver Energy Modeling Guidelines, the provision of City of Vancouver Energy Modeling Guidelines shall govern. This is the BCBC. So the BCBC pointed back to the City of Vancouver's code and said, if there's a conflict, go back to the City of Vancouver's modeling guidelines. So the problem with that is this, which is this is coming out of the VBVL's energy modeling guidelines, where overall thermal transmittance fenestration doors shall be determined in accordance and blah, 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 blah. But ultimately it is this based on the actual area of windows and not the standard NFRC 100 size. So what we got was RJC and a few other engineers in the room that went, hey, we're struggling with the whole building modeling side of this. Frankly, we can't make some of these net zero buildings work. We can't make some of the higher energy work. So this is what the code says. And we had projects, we, meaning collectively, and Dave first, with, we want you to model the project specifically. And this was happening during, we just complimented you, but you missed it.
You're so close, Dave.
So we got to this place with these projects where we were being asked as manufacturers, we want project-specific modeling. And it was being done at the, call it, either at the estimating stage, and getting project-specific modeling is frankly an effort. And there are ways to get there, and there's, area weighted average, there's actually like being project specific with the modeling. And depending on what direction you want to go, you're ranging somewhere between, to call it $1,000 to $5,000 for kind of what that modeling is going to turn into. So as manufacturers, we were being asked to kind of incur this cost up front. For the amount of projects that we go through, that is untenable. And frankly, we all go through certification for NFRC so that we have apples to apples data. So I'm not going to get too much into that because I'll actually get to point to that a bit more later. But so we're in the background having these conversations. I've got a few projects. Dave has a few projects. We had Anton Van Dyke that had a few projects where we were all kind of dealing with this, and we were trying to find a method to come back and have the conversation. So that's where our hero showed up, and he put together this. He totally, his 30-page document was my white horse there for a couple of projects.
For one project, yeah.
Yeah, for one project. But we had, like, Jomo had put together this paper that was kind of outlining, okay, here are the problems with this conversation. And this is, like, I don't want to steal your thunder on this because I think this was your favorite and that's become my favorite. But this is coming out of the City of Vancouver's guideline. This document's not intended to be an exhaustive set of technical administrative requirements or best practices for energy modeling. And these guidelines are to be used in addition to the applicable requirements for energy performance modeling as written by the National Energy Code of Canada, NECV. As stated above, these guidelines are intended to be used in addition to the applicable requirements for energy performance modeling as written by the NEBC. So we found ourselves in kind of this, frankly, pissing match with the engineers that are saying the modeling's not working. We can't figure out how to make this specific enough to work. And as manufacturers saying, we can't be expected to incur $1,000 to $5,000 of cost before we win a job. So what do? So I'm going to hand this section to you because this is really where we get into the technical weeds. And as you guys will learn quickly, I have just enough to be dangerous, but we have some professionals.
So I'll just go back to one. Yeah.
Yeah. I want to go back.
Yeah.
So go back.
Nope.
I just want to point something out. One more. What is a conflict? What's the definition of that?
Okay. Discrepancy, or when one's stating a solution or an option that's in direct opposition to the other. That's what I would say.
So if you know what those two paths say,
Yeah.
and what their directions are to work, if you not know that there's already a conflict.
Two? Like, I'm trying to understand when you would go, hey, there's a conflict here.
If one contradicts the other.
And that's kind of actually where this conversation starts, because
As you're right here. So the applicable requirements of Part 8 of the NEC and the City of Vancouver Energy Market Guideline, that was in the code in the 2012 code. It was just in 2018 they added this little line. What I think unfortunately became the reality is people only read the City of Vancouver Energy Modeling Guideline and said, well, that's telling us what to do. So it's now the governing document. Let's forget everything else that is written. And I said, that's like an iceberg. You're like seeing the top of it, saying we're only going to look really hard at the top. As long as we're far away from the top, we're good. And then, yeah. So that's the problem. In all reality, there's very little conflict, and it's trying to decipher what is the actual conflict that ends up happening for fenestration, because this is not fenestration alone. This is everything, right? So yeah, our biggest issue right here that came up for us. So a little history on Layton. I know a lot of you know us, knew my dad back in the day. So we, like 2011 was the first inquiry about thermal. That was like one of the first kind of like, do you guys know anything about thermal? We started having modelers in 2013. We eventually decided to become an NFRC simulation laboratory. So we actually do certification simulation for NFRC and for manufacturers. And it was this like abandonment of the NFRC standard size. And what my thought was like, okay, so everything points to things being NFRC or CSA approved. We've got buy-in from the good guys in the industry. We're consistently fighting might be a too strong word, but clarifying what those values represent versus other European models, or the results of those values. So we have buy-in for this, and all of a sudden the language is like, we don't care, get out of it. And there was emails that were passed around asking for clarification from people in the city, and basically the city's like, well, we're not the law, like we're not going to tell you about NFRC 100, but yeah, it should be size specific. And so it really opened up this can of worms of like, well, why do we do NFRC? And I think that's what got that first paper going. And then if we do it, if we do decide that there's value there, which I think it is, it's validated, it's third party acknowledged, everyone's playing in the same field. We'll kind of go through a little bit of the history of it. For those that already know everything, it'll be some review, but this really is kind of a working paper that came out of the task group that we ended up putting together with Ben Canada. So yeah, this made me laugh as soon as I dug into it. And then I also did a review kind of like, well, what was happening before we had this huge explosion? I think what caught people off guard the most with the City of Vancouver Energy Modeling Guideline, I don't remember whose project it was, but I think it was Anton, Centra had a project in Victoria, and they're like, got to meet the City of Vancouver requirements. And he's like, it's in Victoria, why do I have to do that?
And then they brought up the BCDC, and it's like,
Yeah.
oh,
And
by the way,
it's
the
part
BC,
of code.
it's
Yeah.
part of code. You
Yeah.
are code required to make this requirement.
Yeah. So in the past, we had methods to pass. Like when I first got into the industry, there was what I would say a threshold model, but a prescriptive method of saying, look, just tell me what my label needs to be. I want to install this window, tell me what my value needs to be, and we'll put that particular window in. We saw triple glaze, I think, in very real reality become a very quickly adopted system because of that, because it was like, we want to lower the overall labeled values so that people can install. Then we had this performance conversation come in. And so the VVBL really had these very clear paths. If you wanted to install a window or a door, this was your threshold model. You could also use performance, and the performance compliance was like the beginning, or kind of the lead ship of integrating with energy modeling. And then there's also the passive house kind of other way that you can use it. As long as you're actually getting a passive house certified building, go ahead and use passive house certified products. So we get to this, and all of a sudden this is just like, no, I don't care. I remember forwarding this to somebody, and they said, well, the wording in VBBL says, I forget what the exact wording, but it's like, proposed solutions in VBBL. Like, it's not like this is the rule. So I'm like, so then the VBBL doesn't even comply to the City of Vancouver Energy Modeling Guideline? Like, how is that the case if that's what they're putting out? So it was all really confusing. And at the same time, I just had this very interesting project that opened my eyes to how bad of an experience it could be. And this is like one of your West Van Part 9 homes, just barely under being like a Part 3 building. Originally, I saw the actual original design. They wanted a window to wall ratio. One of those money's no optional here. The whole backside was glass, so it was like 40% window to wall ratio. The original said actually was 43%, which I laughed. But they had this, and they said, we're going to do step 5. We're so excited for it. We can justify it because it's shaded in areas, and all the models were pointing to it working. And I talked to the energy advisors. We reached out to 3 companies, and we said, we got to get a U-value of 1.0 and a solar heat gain of 0.5. They said, no problem, let's build it. But we want to use local wood windows. And they called a manufacturer that we were working with, and they said, hey, can you give us the values? It's like, no, not even close. And it was
So for people in the room that are not intimately seeing glass out there in the industry, a 0.5 for a triple glazed unit is essentially clear glass.
Yeah.
Maybe you get a 180 out of that, but that's pretty unlikely. You that's kind of where you're going to be.
Yeah.
And so for most buildings, that means you're cooked.
Yeah. So So this, and yeah, not only that, not only you're cooking, but you're right on the water. So your most exposed area is like, oh, enjoy that room for 4 months of the year.
And I'm not quite sure how you get a 1.0 with that type of low coating.
Well, that's part of the problem. It was evident that it was based on some European modeling. So one of the things that I've talked to several people is there is ways that this is not the purpose of this presentation, but I have one separating why European values and North American are so different, but you can't get this seesaw effect. You very much, the way that we use the metrics, and it's modeled in the NFRC program, and CSA is totally harmonized, they come down and they go up fairly linearly. So what this ended up being was several iterations of models, changing out glass. We have to get a higher solar heat gain. Can we try double glazed over here? Just bent on getting this step 5. And finally, after like this year, this project is being closed up now, and I started it May of last year. This was a part 9 home. And I just sat and I said, you either are going to lower your window to wall ratio, which they inevitably actually had to do, or like you're going to have to change something in the envelope, because I can only give you so much. And they're like, they had these funky ideas with wood. I'm like, wood already performs really well. Like, there's only so much you can do. And so to run all these models over and over again, it was several $1,000s and months of work. And at the very end of it, and maybe I shouldn't take their name out, but the reality was they couldn't even hit step 5. So all this work and all this stuff, and everyone was super excited for this home, and they all blamed the window people. Like it was our fault, you know? And I came into this industry with the window people being blamed. And I am very defensive of the industry because it provided a life for me while I was a kid, and it provides a life for my family. And so knowing that there are interpretations that exist out there, that there is limitations to what NFRC can do and generate what it's providing, and also understanding, if we understand what it is and how we can use it, there are solutions out there. So that's what brought about this whole thing. And then, yeah, go right ahead. You had a similar experience. Right?
Yeah. So, I, comically doing this in the sense of, a year of modeling and, just offhand, I don't know. I would hate to quantify whatever you went through for a year with them, but it's that. I'm confident somebody's just shoveling money into a furnace because they're dealing with the amount of models and remanufacturing and the time invested. And as he said, it's part 9. So like I've got an experience with a multifamily build where we had an energy modeler that after the shop drawings are done, after everything was confirmed, we had already manufactured the windows. The engineer came back and said, by the way, we want you to project specific model these. That is bananas. We already had all the windows manufactured. And now you're coming back after having standard size modeling and saying, oh, by the way, it is code for you to have to model this per the project. If things had gone poorly, that could have been an entire, it was a mass timber building. That was for us in the like $850,000 worth of window range. That's untenable. So we were in kind of this state, I think as an industry, we were kind of up against this wall. So before we get into how we started solving it, I kind of wanted to backtrack and give the group a little bit of history on NFRC. So there's things about NFRC that there are people in the room that had practical experience on how it actually works. So I tried to find things that you probably didn't know about it. So I found this really interesting snippet that was made by the original NFRC startup group. So NFRC, fascinating. You've got 1989. The U.S. government has done a paper, and what they have found out is that there is 40% less natural gas and oil than they had projected. It's a full-blown panic, and the government's going, okay, we've got to fix a whole bunch of things. And what they do is they push back to ASHRAE and they say, guys, we have to have certified values for this. If there is not, and we can't squeeze the industry into energy performance, this isn't going to work. And so either we're going to create a certification or you're going to. And so in June of 1989, about a month after this, ASHRAE meets down the road in Vancouver at the Hilton Hotel, and they can't get a boardroom, and they're sitting at the bar. And so as ASHRAE, they're sitting there and they're talking about, okay, this is a fundamental threat to us as an organization. And so there's a picture in the book of them jotting out what the NFRC logo is on a napkin. And that is the beginning of NFRC. So there's a couple of interesting quotes that I pulled from the book that I thought was fun. So from Anderson, one reason we decided to proceed was the folks from government told us that they wanted this to happen, and if we didn't do it, they would. And then the Oregon Office of Energy, we must guarantee the integrity of NFRC ratings if we want the system to be accepted, because the possibility of each state utility developing its own rating system would be chaos. So that is kind of the beginnings of why we're here talking about this. Because, I've been asking this question for a couple of years now. It's like, why NFRC at all? Because in 1989, 1990, we're not talking about a time period that anyone gave a shit, frankly. Excuse my language, guys. But what was interesting is that you've got a whole bunch of articles that are coming out from NRCan and from a couple bodies in the US on kind of fundamentals of Windows. So double glaze, triple glaze, U-value extrapolation. It's a fascinating set of articles from kind of 1988 to 1996. A lot of R&D during that time. So I kind of already went through some of this, but ultimately the US and Canadian government made it clear that a uniform energy certification was going to be made. So that's kind of how we found ourselves looking at NFRC 100 and NFRC 2. So this is pulled directly out of Innotech's site. They have kind of their scope and test procedure and results. But ultimately, NFRC 100 is designed so that we can get frame and glass U value out of a fenestration product. More or less, there's more to that. We can extrapolate that a bit, but that's NFRC 100. And then
for public comparison.
Public comparison.
Yes.
Yeah.
That
So
is
I'll
the
get there. But
yeah.
so the idea is, and we'll get into the next slide, there's a series of product types and their sizes that essentially you're doing the testing. So NFRC 200 is covering your solar heat gain coefficient and your visible light transmittance. There's also CR, or condensation resistance, which is a whole barrel of monkeys, but for the most part, solar heat gain, visible light transmittance coming out of NFRC 200. I am way oversimplifying this, so anybody that wants to jump in and give more information, please. But the point is, as a manufacturer, what it provides us, and frankly, it's a pretty unique feature when I look at the landscape of energy modeling, it provides apples to apples comparison. So like this conversation we were having about U value and solar heat gain, as manufacturers, we kind of can talk apples to apples and BS check each other. Like that's nonsense. That number doesn't exist, and if it is possible, prove it. That's actually really hard when you're doing, call it size-specific modeling or project-specific modeling.
Yeah.
You really have a hard time getting there. So NFRC provides us something fairly unique in that way. It's imperfect, just frankly. It is not a great way to get to a very exact model. The Germans would be offended. So another piece for us as NFRC is we require temporary labeling. We have to have temporary labeling for our products. That, or if you've got a Part 3 building, you're going to need to use Part 5 in order to get the energy modeling, which essentially is you're going through NFRC modeling simulation in the background. And as I've said in the next one, you've got this chart, which gives you what type of fenestration and kind of their sizes that you're going to be doing that modeling to. And so we're all playing on an equal playing field using NFRC 100, 200 within reason. There's definitely things that are imperfect about it, but again, it's a nice apples to apples comparison. But this is the problem. It's like when we're really talking about efficiency, Jomo.
Yeah. So we have a window, certified window. We modeled it to the standard 15 by 1200 size for a fixed window. And all we did was change the width by a little bit. And you get vastly different few factors. And so I think like it speaks back to the project you're on, it speaks to the project I'm on. You can't dump NFRC and think that we're still going to be able to regulate. Because what happened in the projects I was on was like, well, we'll just get a European window. And it was like pulling teeth to say, even if it's European, still I'm going to have to model it to NFRC standards. And so I think what's so valuable about the program is that not just the apples to apples comparison in the sense that the public can see it, but everyone's playing in the same sandbox. So, yeah.
On specific sizes.
They are, but not the same ones. There's actually
I understand, but I'm saying, even if a client says, well, I get a European window, the value they see is based on a standard European size.
It's totally different, but you are right. It has its standard size, but that's one of multi variables that make it stuff.
And I can't run a calculation. Yeah.
Them thinking that because they can get a European
Value.
Yeah.
That's going to apply to some other size.
Yeah.
Well, no, it doesn't.
Yeah, exactly.
Right, okay, just wanted to clarify.
They still don't need code.
No,
Like
that's right.
it's super clear.
Yeah, at the end of the day,
Like air and water too,
have,
right?
they either have to have 10 NFRC data, CPD numbers, or you need to go through part 5 and do the thermal modeling for it. The hot box thing is a whole nother conversation, but has that been pulled out? I remember we had anyway, that's a different conversation. But like I said, there are some problems with NFRC. When it comes to modeling with NFRC, I think collectively we as an industry are struggling with combination frames. So how we're going to do average weighting when you've got, call it operable, fixed. There's, what prevails? Like, is the weakest element the thing that prevails, or what does the structural steel in the window look like? It is a whole can of worms to kind of unpack how accurate does it need to be? And ultimately, I'll kind of give away the deadpan at the end. That's the real question. It's like, how accurate does this need to be? Mullion coupler connections, like how much does that matter? There's a little bit of conversation at the end about that. And then I kind of hinted at the additional metal added around the frame or used to reinforce it is a conversation. According to our conversations with NFRC, they feel that this particular thing is actually covered under the schema, that everybody has to be modeling so that the appropriate reinforcing it is every product and the certifications lined up. That might work for companies that are producing the same size windows, selling to Home Depots or Lowe's or big box store. I frankly don't see it in the Lower Mainland and from custom manufacturers. There's no business case for that. So I would like to dig in a bit more about that and have some proof of that, but I'm calling BS. So there's another problem with NFRC is there's no BS check on the NFRC outputs. So when you put in the modeling data, there's no engineering flag that says, hey, by the way, this is way outside parameters. This doesn't make any sense. There's nothing built into the calculations that help with that. You can kind of call it as a certified NFRC simulator that you should know. I think that's call it an ethical responsibility kind of conversation, but the calculator itself doesn't do that. You have to be a professional and call it. So we kind of talked about vacuum insulated glass when we were doing the tour. Introducing new technology into NFRC is frankly a struggle. It's not designed to deal with new technologies. It has to go through it. There's a lot of additional work, and essentially NFRC has to say, yes, we're going to take it. That's the reality of adding something like vacuum insulated glass to it. Providing size and building specific modeling, which is kind of the whole conversation here. Yes.
Oh, even that, yeah.
Correct.
Yeah. Or to get your CP.
It's not impossible.
No, it's a process.
not. But it has to go through, they are the gateway for anything that's new. That means if the industry outside of NFRC has decided there's a series of things that we want to start to see implemented, NFRC has to be good stewards and bring it into the library. That's not a bad thing necessarily. We probably should have gatekeepers, but it makes implementing new technologies when the landscape is changing fairly difficult.
Yeah.
I would say that's a barrier to entry for some of the changes we're now seeing. But I could be wrong. I'd like to see how NFRC is going to react to vacuum insulated glass and how long that's going to take for them to add that to the library.
But I mean, if you follow it's like, well, it's project specific.
Yeah.
And they don't want NFRC. They want a project specific value.
Yeah.
And which is not based on NFRC. So
we're going to get to that portion of the conversation because we've now had multiple conversations with the City of Vancouver and these handful of energy modelers. And this is even why we can talk about the calculator at this stage, is because we've gotten buy-in from how they want to see it moving forward. And I think the BSSB and the City of Vancouver were both really clear that it is not their goal to discredit NFRC. That I've got an email in this. Anyway, we'll get there. We'll get there. So as a summary, NFRC is imperfect. The building model needs to be a bit more accurate. And for us as window and door manufacturers, we depend on it. So where do we go from here?
Yeah.
So after going through multiple conversations, the City of Vancouver agreed to meet with us and FTIA and a few other players at the table so that we could have a real conversation on where do we go from here? We've got obviously this problem where the engineers need the buildings to be modeled more accurately. And we as an industry, frankly, don't have the tools to give them more accurate information without completely reinventing the energy model. So we sat down as a roundtable and we had discussions on how we were going to approach this. So this email is a result from that meeting, which we had some good conversations with Jeff Baker, who we'll get into a little bit of his paper that he wrote back in '97 that essentially says that based on the information that NFRC outputs, we could create some project-specific or size-specific modeling. That really this was a bit of just an algebra. We knew what variables were missing from the calculation, and by knowing what was missing and knowing the data we had, we could output the information we were missing. So that's what happened. We got through this meeting and everyone agreed, yes, we need to continue to maintain NFRC, but we still have to figure out a way to do this size-specific modeling.
Yeah, I'll take it from here. So anyone who's been involved in NFRC, we've all had all our time that we love modeling boxes. My kids, if they ever see me working on this, are like, Dad, why are you drawing squares? So, but it's really to generate, the three things that the program needs to run. You import, you build in a window program, you import a glass, you draw this. This is from the NFRC test, so this is not real, but you draw the spacer bars, the frames, you sign all the materials, and then you run it. And it gives you the information that you need for the thermal values of the center of glass, the edge, and the edge and the frame. The edge is that 2.5 inches of basically the thermal values of the center of glass are being negatively affected by how the frame performs. So that's essentially just this kind of muddy area that they recognize, okay, there's an interaction between these two. If you actually, this was clear and you could see the isotherms, they can be all over in a frame based on, if the reinforcing's in there or how the voids are, insulation, but they kind of are still a little, I don't want to say wonky, but that's the word that's coming to mind. Essentially though, once it goes past that 2.5 inch, they just straighten out in the IGU. So the isotherms themselves are showing you what's going on. And then this is just representative of the overall value is just a representation of that size now, because this is a model that just goes on forever. And then when you import it in the program, it basically sets the parameters of what that size is. And just to break it down to like what the actual program is doing, which will bleed into the calculator, it's essentially just deciding, hey, like it's going on forever, but I know there's this 45 degree. And so I will break down all the area from the values that I need, and then I will generate a total thermal value based on all these components. So that's all the math that's going on in the background. Calculations are always great, but I love when you put them into a spreadsheet and they work. So yeah, breaking this down into math, that's just a simple way of looking at it. And so essentially how we get those is, for this particular window, I created an IGU using the IGDB. Oh, sorry, I don't know how to. Yeah, Ivan likes your lab, guys. He says he's been here. They're waited. Oh, actually, just close my Teams.
Gotcha.
Yeah. All right. Yeah, the IGDB, I create it, and then it does not have any size related to this value. It can be as big as small. This IGU or the center of glass values are always going to remain the same. So basically, it's indicating these. Oh,
man, persistent.
Well, Ivan also likes JRSs. Shut up, Ivan. Thank you. Yeah, I know. He's not saying anything terrible. Okay. If anything comes up, is the opinion of Ivan Chu and not Layton Control. I'll put it that way. Yeah, yeah. So gotta do that legal, right? So we take that's generated, and then those that model. I don't remember whose this is, so I figured I'm safe enough to show it here. But we model all the properties, we assign as per the policies and procedures. One of the biggest challenges that I have, one thing you said, is the no BS check, garbage in, garbage out. The only errors that show up in NFRC are errors that are built into the program saying it can't run. There are no errors that if I just make this a hunk of aluminum, that it's going to be like, whoa, that's incorrect. And one of my jobs inevitably is checking other people's stuff. And the unfortunate reality is, even people who have at one time been certified, they don't keep up with the policies and procedures. You will miss things that will affect your values. So having this accurate is extremely important, and that's what gives you once you run it with the IGU imported, it gives you the different values that you need for both the frame and the edge. And then in the program itself, that's when size matters. It has some of the U factor area for this particular jam, and it spits out an overall value. So those that already know it, they know. This is just explaining the math that's going on. And at the end of the day, when a manufacturer goes through the process and gets an approved CPD, the labeling that they would need, they have that IGU that they've put in and the frame type. So it's listed as specific frame. And then it gives you the three. This is an American. We actually use CI in Canada, so ignore that. That has changed. The NFRC actually has a tool now for CI. So I believe in the update, this will be dropped, but currently these are the 4 numbers that actually we're looking at. So I brought this quote up from CPD like 2.0 info. And my favorite part about this is that anyone can search it. You do not have to be technical. You're a building code inspector. You're someone who doesn't like the color of their window. You can figure out what it is.
If you're a homeowner, you can check whether or not what you bought is what you were sold.
It's verifiable, which also means that there's liability on NFRC. We are actually given something back by saying these values are true. Oh, but I took a thing and I checked. No, I put the frame I put in there. I put the glass that is approved, certified. This is all what I did. NFRC has said it's so accurate, I can use that number. So I like that on that standpoint, that this is something you see. What you don't get though, if I go up, is you don't get all of the information that you could do to just basically say, okay, I've got this, I know what frame I'm using, bam, 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 change my glass. Like you could run this math by yourself if we had all this information. So it really only gives us the final number. So we thought, along with, and I get to Jeff's paper, I should have put it before this, but is there a way to create a linear calculation using the CPD? And Al Egalis was the first one who told me about Jeff's paper, and then I saw Jeff at the NFRC conference, and we started talking. And his original paper, he's changed some things. He has a new update that he's working on, but at the same time, we're part of the task group with NFRC, and there's a meeting at the end of, it's next week, and we're actually talking about the commercial calculator that they're building, which follows the same math. So there's several parties looking at this the same way. But from the CPD, like I said, we have those, it's based on the standard size. So we know the size that it's being modeled to. We know what the total U factor, the total solar heat gain, and the total visual transmittal that we're having. And it also gives us the center of glass. And then from the drawings, and this is one of yours, Adrian, here, is I can figure out what the site-specific average size is, or every single window size is, from the drawings, from order sheets. Some people use Google Smart Sheets, and they list every window that they're ordering and all the sizes. I mean, it's quite easy to get that. And then I also know I can confirm the center of glass value from those drawings. But it leaves us with these unknowns of like, what do we solve? One of the biggest problems is we don't know the size of the frame. So because we don't know the size of frame and how much that's going to impact, we know its center glass can go forever, 2.5 inches once we give the parameter size. But like, how much is the frame cutting into the center of glass? I don't know. It doesn't tell me. I don't have that information from the CPD, which then prevents me from knowing like what's the U factor of the edge or the frame, what's the solar heat gain component to that with that frame. So like I said, Jeff's paper here, basically saying, hey, we can use these values by doing simple algebra, finding out what the unknowns are, figuring out the knowns, and then calculating so we can figure out the frame data to then run an analysis. Now our only variable, because we solved everything, our only variable is changing the size. So this was released in '97. So obviously, I mean, I'm going to have an update anyways. Some of the procedures in which NFRC did things has caused an update, but we've worked with him to kind of verify the modern calculations. And because we know the known size, that's what allows us to calculate it to the unknown size. Sorry. So this is how this looks in like a graph of what I was just saying. We don't know the frame, which impacts us from being able to separate or calculate the difference of what's going on here. And then this is the impact of some of the stuff. So regardless of frame size, your visual transmittal effect is 0 with frame. It only takes into account the exposed visual area. And solar heat gain is affected a little bit by the frame, which is one of the reasons that we're different than Europe. They consider solar heat gain different, but because we take into account the frame. But this is like our little secret in the bag. What's that movie where they like solve the German Enigma code with Cumberbatch, right?
Yeah.
Yeah, no one remembers the movie, but we all remember watching it. Yeah, it's like
the Enigma machine.
Yeah, this is like the Hail Hitler that let them solve it. The thing with that Enigma machine is they couldn't figure out which like items or, and I'm going deep now, but the symbols represented different words. And then they figured out that at the end of everything they put out, it said Hail Hitler on the bottom. And it gave them enough words or enough letters to be able to read the whole thing. So this is it. This is our little Enigma solver right here.
Rosetta Stone.
Are you comparing yourself to
solving? Yes, I am. Yeah, Benedict Cumberbatch. Yeah. We'll go with Benedict because his career's on the up right now. So yeah. So this is essentially the math behind what I'm explaining, and we're going to walk through this. People smarter than me put it all together. And the reality is, like, let's assume, because we know the set size, so this is a fixed window, then we know that VT will exactly equal, the VT total will equal the VT of glass. But we know there's a frame. And that frame is going to be 0, which means that the VT total will be less than what VT glass will be, visual transmittal glass will be, because we're losing some of that overall area. And because we're losing some of that overall area, we actually can solve what the fractional frame fraction is of the impact of that overall area, which then allows us to have an average frame height. Now, I say average frame height because it's looking at this all around the perimeter. If you have like a door that has like a really wide, bottom rail, thank you. It's going to average it out with everything. But as far as NFRC, that is irrelevant. Doesn't matter. It's running the program. If I went back up, you'd see the frames are cut. It's just all based on the area impact. So it actually gives us everything we need to solve. The only difference is it doesn't separate U edge and U frame. It combines them, but that's actually okay because even in the NFRC program, what does it do? It combines them. So we are able to make it so the only thing we have to change, or the only thing we have to in the linear calculation, is use those values and now change the size. So essentially here, projected frame dimensions is solved. We have the average frame height. We have the average frame U factor and edge factor combined, U factor, and we have the average solar heat gain for the frame profile because we already have the solar heat gain and the VT from the IGU itself. Center glass. So there are some potential sources of inaccuracy, and this is getting way down into it. The CPD only rounds to 2 decimal places. Oftentimes I get someone asked when it was threshold, like, what if my window is 1.226? Like, does that mean 1.22 or is it now 1.23? This is your 2 decimal places. That's all you can check. I like that. I like telling the city is 2 decimal places. Have a good time.
Yeah.
The variation between frame widths around the window. So that's talking about kind of that it's spread around the aspect ratio. So like, there is some potential difference. It's too far down. I'm like, it's gonna be thousandths or 100,000ths. So it's not even something I'm even looking for. I just know it's a possibility. And then this is actually built into the thermal program. Essentially, when you import glass into the program, if it's a curtain wall, you set the height at 1900 millimeters. And then if it's a fixed window, you set it to 1400. It's just an import. I also haven't seen a discrepancy yet. We're trying to run it, but it's something we know that the program is just slightly different on. But at the same time, it is so I only bring it up because of this group, and I know that we're in the thick of it. So when we want to release an actual calculator, we are confident. And someone will say, well, what about this? Be like, it is so insignificant. Like, don't even think about it, especially when you consider this first one.
Well, that first one plays a critical role
Huge
in where we're heading in the conversation, which is again going to what is going to be accurate enough.
Yeah.
And the truth is, at least in what we're getting from NFRC, we can't go deeper than 2 decimal places. That's as far down the rabbit hole as we can go until NFRC says, well, it's time to do 3 decimal places for some reason.
Well, I won't tell them.
Yeah, please.
Yeah. So where this doesn't work, so we're relying on the certified data. So, you know, as a certified simulation lab, I know that LEAF is released, or has already released the LEAF program. That is intended to make it easier for more SKUs, more manufacturers to get themselves certified. There is even talk of dropping the physical test. There are more and more old dogs retiring and more people saying, hey, we've checked this so much. If it's certified and we already have IAs, why are we doing physical tests? So then Canada wants to
you
keep
tell that to
prodding that.
Energy Star so that we don't find ourselves doing it twice.
Yeah,
but that's
I agree. So there is talk because the program is designed in the way it is to be simple and verifiable, and they've checked it enough that if it's done right, it is right. This is all the conversation right here, and reinforcement is where we are finding ourselves currently caught up against the questions with BSSP and energy advisors and so on and so on. So the real question is this precision versus accuracy, going back to how we used to do things in our idea, because, you know, there's several of us on staff who do this. We always looked at this as like a kind of order of operations, like, hey, I got this project. Okay, what are your labeled values get? Oh, they all are below the threshold. Great. Have fun. Don't talk to me. Do your job. Then they'd say, oh, I have my sliding doors, path B, my sliding doors are just above the threshold model. okay, fine. I'll take all your labeled models and I'll do a weighted average because your sliding doors are only representing 15% of the whole project. Let's weight it out. And then we know overall you're below the threshold model. Or, hey, I've got, oh yeah, that was it. Yeah, that's class B. And then pass C was, okay, I have some weight, I have some labeled, or I'm totally importing. I have a whole new design that actually falls outside of NFRC or a new configuration. We have like rake windows, triangles, all sorts of stuff. How do I get this passed? Okay, we'll do a simulation for you. We'll run it. Obviously, most time consuming, most expensive, least, and then like all in the manufacturer. Good job for getting certified. And it was not like there's not precedent there. Oh, I don't know why the colors didn't show up. Oh, I stole this from another slide. So I said something really profound here. I can't remember what it is, but you know, NECB has different compliance facts. It goes back to what you said, Terry. Like, so we just abandoned NECB all of a sudden when you guys had compliance facts built in there, which we took the same pragmatic approach when you needed to meet this or ASHRAE or whatever we were going with. And so this is actually what brought us to Jeff. So Jeff created, this is just a screenshot of several models that he did, where he, in the background, it is doing all that work by inputting, and this is comparison. So this is my total for the model size, casement, awning, fixed, horizontal slider. These values are all going to remain the same because this is what's coming from the CPD. So I'm putting this in, and then I'm getting my center of glass values as well. I know what those are. I can look them up in the window program in the NFRC program, or a window an IGU manufacturer could provide that data for you. So we put that in there. And these are just, he just wanted to compare different sizes outside of the standard size and say, what would we get if it was size specific? And how different would that be if we just modeled it with the calculator? And so some of these were modeled to these sizes, and then the other ones were using the calculation. And the discrepancy is totally insignificant. 2%. Yeah, 2%. And so then he's like, well, I'm really concerned on some, like, I shouldn't say he, like, one thing he didn't have was commercial product, aluminum product. And so the biggest ones I picked, these are two where I got the biggest variation. And it actually makes sense to us. So we did a curtain wall, we did a window wall. You know, these are set up a little differently in NFRC. So there's 2 units, half mullion, and how they do it. So we modeled according to that standard as NFRC size, and then also ran the calculator. And the reason why we're seeing more discrepancy at the very top is because these windows are so small. And remember that muddying of 2.5, aluminum just frankly performs really poorly. So because it's so small, your center of glass isn't getting that opportunity to offset how poorly the edge in the frame. But like, who has ever seen a 300 by 900 vastly on a project in curtain wall? Like, it's never going to happen. So there's obviously more math that we're happy to check on this, but we're confident to say like the error is like plus or minus 1 or 2%. Like, it's so insignificant, especially if you're already asking us to provide it to 3 decimal places when NFRC only provides it to 2.
And we're going to go through an actual like step-by-step with the calculator, so you can guys see the inputs in and kind of what that output is. So it's not just a screenshot, but
yeah, after lunch.
We're using the CPD number versus actually doing the.
Yeah, so the difference between these two, you're right, yeah.
The 2% is from someone actually modeling it totally to NFRC standard. For Jeff's, these were all submissions that he did to get their CPD. So he's actually comparing exactly the CPD to what he modeled for CPD. Now, I don't have one for curtain wall and window wall, but I like ran through it, had it verified by somebody else. Like, yes, this would match exactly how you'd model it for CPD. And that was the same. The error was consistent is what I'm trying to say. Yeah. The hope is to have someone who's like, yeah, I will do this. Traditionally, part 3 is not gone that route, but NFRC is capable of doing it and they want to do more of it.
And so the one we'll go through, we had a project where we had to get project-specific modeling for, and so we're running essentially that project-specific modeling against what the calculator is spitting out. I think what was really, anyway, I don't want to take steam away from that.
Yeah. So basically what I came back with was like this whole old VBBL compliance path B, which I think I'm like the only one who uses it. Everyone else is like, oh, it's the NFRC calculator or whatever. It's just like, hey, we can generate size specific, but let's use the CPD information. Let's use the labeled values to get it. So this is just like, we started a draft because the City of Vancouver is recognized that it needs updates. And this is, several parts that are under review. We're hoping that NFRC actually generates this document. So it's not just independent. I know Jeff is looking to do it, but if it has to be a FEN Canada initiative, it will be, to basically say, you can generate site specific without having to do a full energy model, which goes from several $1,000s in several days or hours or whatever to knowing which system you're using, the glass you're using, and your sizes.
10, 15 minutes to maybe an hour of data input into a calculator.
This is just explaining, I don't remember our break point, but Foo's not here yet. So
Pretty
we can,
close.
Yeah.
And my thought was that we can get through a little bit more of this and then maybe just
see
do a
next.
quick.
Okay, I'll stop after this one.
Yep.
So this is just explaining a little bit more of how we generate a final number, because I'd say this is actually brings us to that original problem. Was one of the interpretations that came out was, well, your worst case scenario is the one I'm worried about, and now I'm going to apply your worst case scenario value to everything. And that is crazy to me, that arbitrarily some consultant picks a casement window and now starts applying that value to the whole envelope is crazy. And so what we had already been doing is, this is just a project where we figured out, okay, we're using all these different systems. This is our glass, and we inputted into a calculation. So this is before Jeff's calculator. We were already doing this. So I only have to model this once, and I have to model this once, and I only have to put the size in once in NFRC window program. I just put in these average sizes for all of this type of window and that type of glass. If there's two types of glass, you'd see CS77 fixed, triple glazed, and CS77 fixed double glazed, or whatever it is, the changing in the low E coating. So and then I'd get an average for each type and grouping type with glass and frame, and the area, the total area that has contributing to the total of each of those. And that multiplies your overall values that are based on these. So we would input these, we'd find out from this size in the window program, when we put there's more data. I could put, BTU and solar heat gain and on and on and on, but it multiplies it by this and then gives me an average number, because 9 out of 10 projects are like, I just want to know what your vision area is. Just tell me what the overall energy numbers are for that. So this is just the math. It's just, okay, overall value is just related to the percentage of each type. So that was what we were doing before we got to where we are today.
The U value you're putting in is the NFRC value, is that right?
Not the NFRC. We would model, and I would model the system, and the calculator that we were using. So I've modeled this system. If I'd already had it modeled, I just pull it up, make sure the glass is correct, group it, and then I would in the spreadsheet, a work page behind this would be a list, and I'll show you when we get through it, a list of, okay, like this is, what is this for, 12%. So I've got, a bunch of window sizes down, and then it just spits it back here as an average size and then the average area impact. Does that make sense?
But what did you model? Did you model an NFRC size to get that value, or you modeled every window?
I only imported a window. Like I modeled it thermal model. I make it like I'm drawing, but I'm not. I'm clicking. But then when I went into window, I made it a custom size. So I left it as a single custom size based on that average size, which would give me this number. So we're essentially, what we're leading to is I took Jeff's calculation saying I can use the CPD value, and then our weighted average calculator saying, okay, let's group stuff. Weighted average actually listed in the City of Vancouver Energy Modeling Guideline. So let's use that weighted average. So it's not like we're modeling every single window. We're still grouping to give us a final number.
You take all of the fixed windows, get an average size,
Yes.
and then model that size.
Yes.
Gotcha.
In the window. I'm just doing custom to change. Yes. Yeah, of every light window. Yeah, yeah. Any NFRC thing. Sometimes we get requests of like, oh, it's thermal, can you do it? And I'm like, this is not the intention of NFRC, because I can model anything. It'll give me a number. But there are set things, but spandrel is something that NFRC can do as well. So, yeah.
How do you arrive at do you take picture window with 150 different glass sizes? Do you actually note those glass sizes and then it gives you the average? Or what do you pick? Because what you pick is
It's gonna be my photo. Yeah,
because you can make that 34 by 48,
sure.
48 by 56, and that whole value is something.
Yeah,
Like
absolutely.
you can tweak that to your
Yeah,
whatever. You can make it work out whatever you want.
totally. 100%. There is kind of two options I have. One is, in the case of Innotech, I just say, hey, you've got these windows in your shop drawing, no quantities, but you guys do. There's 12 of this size. So when we input sizes, if it's the size and there's 40 of that, I just do the two size and 40, and that will calculate how much impact it has. I can do it individually. I've had clients that are less inclined to give me clarity on their sizes, and I'll go through the shop drawings and I will find every single size. If it's rake glass, I will take an average and figure out what my size is to get that like overall impact of that. Same thing if it's a triangle. That's what we were doing. I would figure out, okay, I need to have the same amount of area. What am I getting when I put that together? So there's two ways that we did that. I always prefer when the client provides it because it takes a lot of time and cost away. So we're both, I mean, cost for them and time for me. But yeah, that is true. The one thing I do like about this model, because it's like, well, how do you verify it? If you change this, well, if I mess up with this, it's going to affect this. And it's real quick to look on a job to be like, whoa, why all of a sudden is this 75%? I'm like looking at this job and like, there's no way that's right. So yes, margin for error, sure. Easy enough to check to make sure that it's accurate. In some things, I mean, like, if I see a bunch of doors, like how am I making sure 155, 130? I mean, a lot of it is that based on the accuracy of the drawing. And when we issue reports, we pull out the drawing, we show our full list so that they can see it as best they can. Hey, Mood.
Hey, everybody. So you just call this size a bit of model.
Yeah. Yeah.
Another way is just using CPP, right? CPP models.
That's the new proposal. Yeah.
And when you just compare them, I've done that with all of these. It's about 10%. Each one you just
So that's the beauty of this calculator. Figured out where a lot of the errors have been. And we're really, really close. So we'll show you guys examples.
There are rare circumstances, especially like you said, on small windows where that margin of error is fairly large. But on the majority of it, we're within that 2% margin.
Yeah, 10%. There's something there. Something's relying on something differently. There is a built-in error that we'll get to where CPD sizes are full frame. So when you have combination windows, there is some discrepancy there. So one of the understandings with the CPD is it potentially could be a little more conservative. But even talking to NFRC, the reason why they split up the models they did was, oh yeah, we know that there's combination windows. The reason we don't certify combination windows is because by being full frame, it actually kind of swallows some of the other issues, which as we're kind of learning, as we're digging into this, might even solve some of the reinforcement issue or make reinforcement a linear thing. Like, oh, it applies to 5 frames, add 2%, bam, done. Yeah, so.
Yeah, so that takes us from kind of this first conversation we had at the City of Vancouver to subsequent conversations we've now had where the calculator was brought up as a solution. We've gone through some of this background work to prove viability. I think we've had great buy-in from essentially the collective that they're very happy with the outputs. There's still kind of this ongoing question of accuracy that we have to nail down, specifically around structural steel and mullions. But frankly, as far as I can see, that's our thresholds at the moment.
Perfect.
When we're building energy models at SD phase, we don't have shop drawing level sizes or combination fits or anything. And so it's like, we kind of just guess at our Q values for the windows, like based on what the NFRC size is. It's like, let's derate it by, whatever, 50%.
You don't even know your window manufacturer at that point.
Exactly. And so, and then like, in that SD phase, it's like, that's the question of like, what's the window wall ratio we have? What's the, like, what kind of things can we do? And it's such a hard question to answer, knowing that further down the road, we're going to have to change this U value of the energy model based on all of this actual information, and it can completely blow up our compliance with energy targets. So I guess the question is like, it's not really a question, or just a comment. It's like, how do we derate that initial NFRC number? So like, what's like a good rule of thumb?
So do you know?
We don't know how to, like, we barely get elevations.
Okay, but what's likely to happen, at least my experience, and tell me if your experience is different on this, but most of the
architects drawing right up front on where they kind of want things to be. And as far as I'm concerned, on most of what I see, that's pretty conservative. They are oversizing most things right out of the gate.
Worry.
Right. So what you will wind up having during SD is you're going
to be over modeling building glazing. Ideally, you should be putting in U value and solar heat gain that is going to be more aggressive than what is actually needed on the build. That's tough. How do you deal with the precision at that side? But
assume worst case.
Yeah.
So using that absolute smallest window, worst case, is sometimes the best move for that phase of modeling.
And you guys, how do you deal with so like in project management we use PERT quite a bit. So it's a weighted average of, call it, best case scenario, worst case scenario, and realistic. And so do you guys have kind of a feel for how you deal with, I don't know, I'm asking the question.
Yeah.
It's how do
like
you deal with
yeah.
how do you kind of balance like what the reality of it's going to be, because that's kind of a balance between historical data and what I'm looking for.
Yeah, that's mostly just experience.
Yeah, I think that's the reality.
Yeah,
this is an imperfect system, and that's going to get into the accuracy conversation.
What do you mean?
So when you're trying to 35% to 65, and then that 35%, like a number.
That's what we do usually for STs. Like if the architect has like a window ratio in mind, we use that number, or asking us to recommend something. And
when I get ST sets, I've got the elevation because the architect is nice enough to get me a picture of what it looks like.
Yeah.
I do a lot of, but that's impossible. You can't do the energy model at that stage. So that's a pushback. Like, how could you possibly do your job without understanding at least a rough understanding of what that is? Like, I'm using Bluebeam oftentimes and scaling the windows so I understand what things are going on with the SD.
Yeah.
Like, if I'm touching it at that point, which I don't always do as a window and door manufacturer, but if I am, I'm scaling it and I'm looking at it that way. I know that's a whole nother conversation. That's a great one, I think, personally, because I'm running into stuff that's trash in, trash out type of problems. But I think that's industry being the same. I don't know how you fix that.
So sometimes what we end up doing is like whatever we carry in the energy model, we know in the specs, be like, you need with your overall size specific window, you value to meet this. But that obviously takes a lot of the factors out of the running stuff, depending on it.
So I think that's where I hate talking too much about it until we get to showcase what the calculator is. But I think the calculator plays a huge role in that, because if you decrease the amount of workload you need to put into it, and as long,
especially if you have, call it like an average of manufacturers and how they kind of plug in, you could run those CPD numbers in the background as like a default with the sizes you're looking for, and it'll output what that energy model should be looking like. So it takes you from
How
about most? Not a lot, most.
There's two, like, you don't know size. That's hard. But one of the things that we've like NFRC is not stupid. They pick the sizes, even though I get it. Sliding door, I've never seen anyone sell a 78 by 78 inch sliding door. But if
if you don't know your sizes, but you know, okay, I have 10% is casement, 80% is fixed, and another 10% good. Got the 100 was doors. I would use the CPD values. That's what I would not change those numbers. And that's going to be that's reinforced in the calculator saying, hey, even when I do a model where I was just averaging from the labeled size, the numbers are actually pretty close most of the time because we generally build on average the size that NFRC modeled to. So that would be my thing and something I think FenCan will put forward to energy modelers. If you do know your size, like check 6 different CPDs, like, who are the main manufacturers? Okay, guess our number is that. Like, not an issue.
Have a script in the background with just a break off Excel that just runs the numbers against the calculator.
Yeah.
Pump things out immediately.
Yeah. If anyone's thinking they're getting a copy of this today, it's not happening.
Yeah, sorry.
This is proof of concept. The goal eventually is to have a very universally made, understood, able to be inputted from someone with a relatively low technical information to just, all they really need to know is their quantity and size and pick the right CPD and you're done.
There's still some work in the background, but the plan is to host this on FenCan's website, similar to kind of how the NAS calculators run there, so that it's something you could just plug in and hopefully get an output.
This concept into their NFRC 100, would that then replace this spreadsheet that we're working on?
So there's 2 things to that. One, NFRC is not looking at it for any type window. So that's also going to kick out part 3 vinyl and all sorts of stuff like that.
Any punched opening
At
kind of.
the moment, they're only looking at their commercial glazing.
Yeah.
But the interesting thing is, Jeff's doing his, we're doing ours. Off of Jeff's come together. We find an NFRC is doing there. We put our math down, and you're like, whoa, wow, like we're doing the same math, so we know it's applicable. There is NFRC standpoint, and it will always be this way, partially because of what you shared, was we are giving you certification. What you're doing with the numbers, and this speaks to those that built NFRC and those that are around today, is kind of up to you. What I'm trying to do with the Cowboy FI, what Fenestration trying to do with Council is like, that is super valuable information, and we should stick to that because it's certified, but we recognize industry needs a tool. And so we're creating a tool that we could adopt across BC. BC is pushing this, could be adopted across Canada. And guess what, NFRC? This is accepted and it works. And it doesn't need a physical model. Well, why don't we all get everyone on board? So that's what it is.
It's fair to say it doesn't have any appetite to become more than a comparison tool,
Yes.
right? It's not meant for building design.
No.
And from what I can gather from our conversations with them, that's not where they're going with this.
No.
Are they worried about liability? They're really happy about what we're doing and the path we're taking, as well as is the city of Vancouver and the province. The city of Vancouver realizes that they've created a bit of a monster, and they're very happy that we've jumped on board and are able or planning to provide a solution. They're very, very happy about that and very eager for us to provide that solution that they will then adopt into their language and into their processes.
Talk about, is your guinea pig commercial system?
We're trying to tackle everything.
Okay.
We actually
It could
do
cover both.
with
Yeah. It could cover both.
So
And that's what we were saying earlier, is that the error for that has been about 2%, except for when you got really small sizes.
Yeah,
Small
if
sizes
you have a
are-
frame system that is not very efficient,
yes,
its
Yeah.
impact
yeah,
when
It's
you go
substantial.
smaller just becomes more, right?
exactly.
It's pretty
Yeah,
straightforward.
we got 300 by 900, 1600.
Yeah.
Original Conair. It's gonna be messed up compared to fiberglass and
Right,
stuff.
yeah, for sure.
But you must have ratings, NFRC ratings on your assemblies for that calculator.
Yeah, and we can kind of get
Right,
into
you must have that.
That is
that,
that
or you have to
base.
model it to NFRC.
So that is the intent. Is this calculator is built to basically, in my opinion,
Hey, industry, you guys adopted a program. We want this to be used and reinforced. and that's one of the reasons NFRC I think is very,
Inclined
amicable,
to-
because we're supporting NFRC here. Let's use that information. The other option, like, and I do it, my team does it. We have someone who brings a product from Europe. I'm like, great, you're kicked into
Path C. to
Path C.
simulate.
I'm simulating everything. So
So you wind up doing NFRC simulation anyway.
Okay, so I'm looking at the project, I've got all my systems in NFRC tested. I go onto this calculator, pop in some numbers, right?
You pop in the CPD number.
And get an idea, and then I approach my client with that. Is that the intent?
You talk about
Yes.
from industry, yeah.
Yeah, I would, well, so I think there's a couple different approaches here.
I've got an energy modeler and they need to make sure the building model is actually going to work. And so I can provide my data back with size specific for the project, and here you go. And, I know for us, although I think NFRC sizes are pretty close, I think majority of what we're doing is bigger than what NFRC has modeled.
more and more.
So
Yeah.
the reality is that I'm performing better on these projects than what I have simulated. And so that's a huge boon, that allows the model to get tighter. And then I agree. I think if I had a general contractor that says, hey, I need to hit these kind of numbers before you even get into the running, can you tell me if this is gonna work? I could run that in the background for an hour worth of work, versus I used to have to pay $1,000 to $5,000 to get this model accurate enough to be able to provide it to
You're
them.
not paying me anymore? I'm just kidding.
Joe, no, you did it to yourself. but
Hey,
you
it's what
got-
industry needs. It's the right thing. And I'm
It's-
tired of drawing squares. So
Yeah,
Yeah.
yeah.
if you're not certified, come to me and we'll get you there. So, I mean, I got plenty of imported work too.
Did you, from a licensing contractor, so you get a cross section?
Yeah.
For each cross section in the building, every time. And we use linear calculate each window based on these data that we get for each cross section. And then for the shading coefficiency, soil heat coefficiency, we use wetted area to represent. So it's quite a tedious calculation. We have to go through each opening to get them the average rating.
Right, so if you're already going through NFRC,
You just plug in the size and you plug in your CPD and you get
Yeah.
output.
In many instances, I think that the biggest
Actually, I can just say that because there's actually layers, right? There's the bidding stage. Okay, I'm confident this is going to work. There's all that. But I think my favorite part of this calculator is I've heard several times, in different things, in different projects where someone gets a tower here and someone gets a tower there, and they're like, man, why is that window's garbage? Like, how did they get this to pass, or how did they get this approved? We have now built in a system that is totally verifiable by everybody. Like, here's my labeled number, here's my CPD. Okay, I'm looking at your window. Oh, that matches the CPD. Great. I don't care anymore.
And your CPD is the window and the glass makeup you agreed to.
Yeah, you're done. You're awesome. And if someone's not, I mean, how many projects can get through and someone's just taping stuff to it and it's not lining up and they're trying to use this? You could train all the energy advisors, all the inspectors on what to look for. And it's that quick to raise up the industry and really, like I said, celebrate those that have done the homework already. So
How do you maintain integrity? Like within that whole, like, I'm just sure, like, how do I scan the system? I'm sorry.
Yeah, no,
I mean, it's not
break it
not
down.
long enough that.
How do you break it?
How do you scan the system?
Yeah.
Like, it's like, okay, well, I've got my CPD, but my average width of 34 by 48, well, I'm just gonna make that 48 by 50.
Yeah.
Right? And I can go through that whole system. It's like, where's the checks and balances?
Sure.
Like, because it's gonna get scanned.
Yeah.
Like, I'm sorry. It just,
no,
it
you're
is.
dealing with it from a white hat hacker perspective. So you just like, now that we have.
The wrong word, scan, right? Like, I'm.
No,
not
it's
looking for
okay.
you to
It's exactly
do
what
this.
you're going through. You're asking. the
Right?
right
How do you get, I'm sorry, integrity, how do you gain this?
There you go. That's still fine.
Good where you're going with that.
Next sheet. Showing.
Project, all of the products in that project and all of the sizes.
Yeah.
So you could somebody that was concerned about being scammed could verify that all those sizes match what's on the drawings.
Yeah.
So you could do a cross reference.
And you have to submit that data.
Sure.
You can't just do something.
Yeah, no,
That's right.
no,
And
and
you're
it's
gonna
another
see-
sheet that we're
it's
gonna
a
see.
sheet. And
Right.
you've got the CPD number that's in this.
They could look at the CPD and the size. They could validate whether or not that's what they're getting.
Yeah, well, obviously we can't make it perfect, but we can try and build in the checks and balances. Yes, like as this is built, I can manipulate this on this front sheet, like in my original calculation, I could just make this, 50 and 60 on this sheet. It would screw this up. Like all of a sudden my percentage would be wonky. If I went into the background, yes, I could make every single window bigger and play with it too. But the reality is that the dynamic calculator we're going to give out, once you input your information, this is locked. So you'd either have to go through, and you couldn't just change like one window. Like, well, I guess you could 1,000 by 2,000 or like 4,000 by, yeah, like you could do that. But it's going to, yeah.
I need 1.0.
Yeah.
So I'm just gonna change things to get 1.30 in my summary.
Right.
And
so,
I'm gonna substantiate it with a 50-page document file.
Yeah.
Good luck finding that.
So you just gotta say on your document, small print. Products may shrink in shipping and handling.
They come over the mountains, that's what they do.
Because I need 1.30 on that document.
Yeah. Right. Yep.
But
So
this summary comes from the other sheet though, right?
Yes, it does.
And that sheet is verifiable by cross-referencing to the project drawings.
Yeah.
So it is checkable.
Well, no, absolutely.
Right.
but
Now, if the drawings aren't right and the product ends up being different than what the drawings say,
if there's
I guess what I'm getting.
that's a whole other, that's a whole other.
Verifying. Yeah, who's stamping it? Who's responsible? Right? Who's gonna take the responsibility? Sure. The GC is not gonna. It's like,
we had this conversation yesterday,
Right.
and like I
He's
said,
not
it's
gonna
an
take
existential
responsibility.
threat on how we look at net zero later, because we're gonna need somebody that verifies this. Somebody has to hold
yeah,
the industry accountable. So let's call it quits for now, because I think we're at.
Let's come back and look at the calculator, and then we're going to open it up to the conversation behind this. So.
To me, this one.
So I guess one of two things. You're going to go through the spreadsheet. Do you want me adding the information for you so you can talk about it on this side, or do you need to be at the computer?
I don't need, when we're walking through your job, you can actually kind of talk about it if you want. See how well I've explained it to him. Yeah.
Yeah, sounds good.
So yes, we're going to jump right into the calculator. So when we first got this, when we first got the program going, I'm like, oh, I've got a job I can do. Obviously, I've zoomed out far enough. I was supposed to cover those. Okay, so you just see fixed. But I basically said, I have modeled this according to, this is not a certified product that I had. It might be, but I didn't have access to the models that were done in the certification, if that makes sense. So I've modeled it, done everything I can to make sure that it's NFRC size. And I've already figured out that, like, well, this average, how we used to do things. And so this project was done. It was presented. Here's your overall values. They were super happy. Job was completed. And I'm like, okay, I wonder how close I can get with this calculator. I basically want to see how quick can I break this calculator. And so when we're walking through your job, you'll see there's like the deliverable page of the spreadsheet, and this is in the background. So we essentially split it up by its type. So fixed, tilt and turn, vent, casement, I think there's doors and stuff. And then I just inputted with the drawings, all the widths, all the height, the quantities, and then I even listed every single window. So that's another kind of check and balance. If you're like, what's going on here? And as you can see, some of them, this fix and this tilt and turn, they're part of the same window because they have different profiles as it would be modeled by NFRC. These are two separate windows. So that's something to keep in mind, that it's going to run the calculation as if they're two separate windows even though they may be combined with the mullion.
So that's actually a great point to make. Like when we get to my windows on this side, if we're pulling apart like the operable unit and the fixed unit, both of those, the frame overall will have steel in it. So like for our product, that's kind of how we deal with that. But if I pull out the operable window and the fixed window, I actually now have additional steel that I wasn't accounting for. That like combination right here, I'm actually being penalized a bit by this system, but I think that's still part of the accuracy
Precision
conversation.
accuracy question, and where are we willing to allow that to exist? So I split it up exactly as if these were NFRC models, and I only changed the sizes. And then I also followed the old performance path. So this is what we modeled when we modeled it as if it was path C. So I'm modeling exactly how I would if someone came to me and it's a European product, they're like, I need NFRC. And I say, okay, I'm going to follow the policies and procedures. I'm going to draw in everything. I'm going to combine it all and give you one value. And this was just like, well, let's pretend that these have a CPD. So I modeled them to the size that they're related to at their size. And there's some discrepancy. So this was the old path B in the case that, hey, I just want to use my label size and just change my weighted average. So the size doesn't matter. It's just the area of each different profile. And there's difference. Not a ton, but there is difference. And based on what your product type is and the size of the windows and the area overall, you're going to have significant difference. So I can appreciate that just using your labeled size and then doing a weighted average is inaccurate. And I think that was something that was meant in the City of Vancouver Energy Modeling Guideline. So then I ran it through the calculator, and man, was it ever good. This number took 2 days, and I think cost the client like $33,000. I was going to say $3,100. And this took 15 minutes, and partially because I already had the sizes. If I had to find the sizes, an hour. So the power of the tool right off the bat, I was like, okay, I like this model. Let's go with this, because I don't like this so much. Yeah, there's a lot of work. And if all that work's already done, where I don't have to model, and I'm getting that accuracy, then that's pretty amazing. So this is to show you what the front page looks like. The way we've designed the calculator, it's still, if you have labels, it actually, as we've designed it, shows you what it would be if you're just averaging your actual NFRC size. And then what is it when you put in the actual sizes, when you take the sizes into account. So it's still weighted average per that, but this is based on the size, and this is just based on the area. And what I like about this model is it's partially another check and balance, but also because it's showing, hey, if I just average my labels, what's a realistic thing I'm getting? Kind of like the EA model. And then, okay, now what's the discrepancy? We're essentially teaching industry, teaching the stakeholders that are getting this information, what kind of window performance should I really be expecting? I don't ever want to see a 0.65 solar heat gain requirement again. And I've seen it on 2 jobs and almost erupted into colorful language. So yeah. And so, yeah, this is basically just split so you can see it into 2 quite clearly, and you can see the discrepancy. But this is essentially the end deliverable that's based on that size specific and just the average of the rated values. Okay, cool. Where are all the inputs? And I think, I'll get to the issues first. One we already identified. This is a combination window. So when it's put into the program, even though I modeled this half mullion here and half mullion there in my actual model, when we put it in the NFRC calculator, this is a full mullion and this is a full mullion. But what's so interesting is it almost, full frame. Sorry, yes, full frame. What's so interesting is it kind of accounted for that margin. Mm-hmm. Here's another issue is, well, I've got this one swing door.
Pause.
Yeah.
Why did it account for that margin?
I honestly believe it's NFRC essentially understanding that the discrepancy when you cause over the whole project is so low that that's why they picked certain sizes and certain configurations. Like this is not a triple slider is not an option in NFRC. it breaks it down to a double slider. Yet in my in the area, I have to account for all three. So I got unique in how I separated this one and separated this one in my area, not my area, my size calculation to account for the total area that that's representing. So this is a swing door, and then I have this in as a double door, and then I also include this as another singular part of that. Now it all worked out in the calculation. So that's one thing to keep in account. And then here's kind of the ongoing conversation we continue to have is, you know, we have some reinforcing in here. Where does coupler T-bars take into account? In fact, even NFRC has confusion with the difference between a combination and a composite product. Their own clarification wording I do not like, because I walk away reading it being like, I don't even know what I just read. Essentially, I think it's because they're like, look, we're just certifying, and industry has kind of made some decisions. The old way of doing things, for instance, this window just got the value was assigned it just on the worst performing window. And I don't think that's right. Yes, now the calculator's accounting for a casement here, a picture window here, picture here, all full frame. But in some ways, it's kind of accounting for some of this other stuff, which NFRC, its own program, is doing on its own. So some of this is more study, research that has to be done. If there's any plea to industry is if you have certified product, even if it's an old job, like let us get in there and try it and break the calculator as much as we can, because the more we can prove what this frame combination actually plays in the calculator, the more we can make the linear calculation simpler and simpler.
So I think what would be helpful as you are playing with this is when you see combinations that you're like, ooh, that messed with the calculator in a weird way, is to start asking for more projects, because we can put that out to the specific numbers. Like, hey, we're going through and we're proofing this calculator. We need things that look like this.
Yeah.
CPD numbers, size, and configuration would be helpful.
Yeah, I mean, one of my most recent experiences with a local lab, so I'll omit that out here because I'm on camera, was I had a lab send us, hey, they want some thermal modeling done with NFRC, and we're running this NAFS, and it's like a fixed window, and then a dual sliding window. Can you give us the NFRC number for that? And I'm like, no, I don't even know why you're doing a NAFS calculation for that, because now that's all they can sell. Like the way it's split up in NFRC is picture and a single horizontal slider window. And I think there's an important thing to understand is, I know when you do project specific, the information can be accurate and even more accurate per se, maybe than a calculator. But what's the discrepancy? Because if I build that window in the calculator, sure, I can't give them an NFRC certified number, but if those components are certified, I could give you the value for that window.
Yep.
And then you're on with the job rather than certification per job. Yes.
So
we can come back to this question.
Let's come back to this question as kind of our final wrap up, because obviously we continue to kind of beat on this portion of the conversation.
So you talk about this.
Yeah.
And I'll play.
So funny conversation, actually. So I when we first came to the project, we kept calling it Project X. And Welcome Elsion was what I got from the project manager. And then when I got on site, we actually had a couple indigenous workers there on site, and then we have no idea. And so it has been, I don't have an answer for how to enunciate that. I keep calling it Welcome Elsion to the best of my ability, and really I make sure it's spelled right in every email, and I call it Project X when nobody else is listening but my team. So Project X.
For me.
I am so sorry to any First Nations that I might offend on this. I just frankly... Yeah, it doesn't have a 7, so
yeah, anyone been to Squamish? Yeah, figure that out.
So this is a multifamily project that we're just wrapping up with. As far as I'm concerned, it was fairly, I mean, the configurations weren't crazy. Most of it's kind of get into, call it like 6 foot by 4 foot type of openings. There's a handful that are a little bigger, but not really. Like I would say this is a pretty easy project. But we got smacked by the energy consultant on, you need project-specific modeling for this because it's not meeting what we all want. And so I went to Layton and I said, hey, we're being asked for this. And so they went through and you guys did the project.
And this is one that's already built, like the windows are,
Yeah. So this is one of those stories. And so we.
Sorry, can I stop there? So the windows are built, now you're being asked to provide. Right? What was the precursor?
Like when you went into the project, was there a spec
There's a
for
spec that
performance?
calls out what the performance is, and we use our NFRC
Okay.
standard.
Okay.
That's all fine until the model is approved.
Gotcha. Okay.
Yeah.
Thanks.
Yeah, no worries.
Keep going.
Oh, there's, you know,
This feels very vulnerable. Our
yeah,
shop
sorry,
drawings
I'm
are
trying to rip through
constant work in progress.
everyone's is.
Yeah.
I see them all. Yeah.
Yeah, so this is, I mean, window and door schedule, pretty common, I find, for the industry. So I sent over the drawings to Layton and I said, you know, I could use help modeling this so that I can provide something back. This was one where, so I should backtrack and make sure there's honesty on the table. This was not manufactured yet. Capstone was a project
was the
in
one that
Kelowna that was the mass timber building. This one was simpler. We were already in the conversations with them. We already had the shop drawings done. We were at production phase, and then I got the call. But like
Were they asking because your NFRC values were?
no, they lined up just fine. It just didn't work for the building. Yeah, so we were running into that. That's a big portion that was bugging me, is like we were meeting the project criteria when we got the tender. So we're getting in and then the modeler's like, it just doesn't work. I need you to go fix your numbers. Can you improve your windows or fix your numbers?
Just fix your window.
Yeah, just do something
Just what you
about
wanted,
this.
Danny. Just a 4 there and done. Yeah.
Attitude, right? It's the window guy's gonna fix it.
Yeah,
Like, you know, like I
But-
you run it.
Anyway, let's not get off topic because
Yeah.
I'm not gonna, you know, we're doing our best to kind of help fill that shoe. Like for them,
It's not working. And yes, that should have been designed better, but we've been in an environment, I think, for the last 4 or 5 years that collectively we're building like crazy. I don't know how collectively we as an industry is holding on to it, but I think everyone's kind of by the seat of their pants. So bad or good, it's a reality. And so we working as a team, especially on a project side, is important. So if I can help, we should. I can't fix the windows, but we can talk about the modeling. So that's what we did. We went and they paid us for the modeling this time, which was rare. That doesn't normally happen. So we went through, you guys did the modeling for it. We came back with all the results. They were like thrilled. Yes, thank you. So all that information was with Layton.
Yeah.
So that brings us to the calculator. So we've already done the modeling for this. So we'll get to see that on the calculator.
Yeah.
And now we're going to do the actual inputs into
Yeah. So what's amazing enough is like, I ran this without doing thermal. Like you gave me your CPD numbers. I got all your areas, I got all your quantities, and I checked your windows. That's exactly where I started. I pulled up window. I created the windows to get the window data. Because if we pull up the CPD, I think I have it.
Yeah, so for those that have not seen the program, this is the window program. It's sitting in the background that does the NFRC stuff.
So you had 2 different window types. You had, 366 low E coating on surface 2, and then clear, and then one with a laminate inner layer. And I just built them in the window program. So I plopped them, I built them in the program, so then I just got this information, the TVIS, solar heat gain, and the U factor. And then I went back to your drawings and we put in here, I just started off. I went over here to sizes and I put in the frame types and I separated them because you had 2 different glazing types.
Yeah.
So if I go back here to the first page, that's the yellow is my inputs. My first input, okay, I've started this off. Then I pick what the product is. Whoa, that's way smaller than I thought it was going to be.
I can, it's okay for us to increase that. You can like.
There you go. Dual action. How do you do that? Okay, thanks. Yeah.
There you go.
So I went down and I just selected because in the background, even though this is just sitting here as a table. This is actually pointing to all the calculations, because remember, we need those standard model sizes to then make it a linear calculation, because we're basing the information that we're getting off those standard sizes. So I go in here and I just select what it is, dual action.
Oh, wow.
Oh my gosh.
That's terrible.
What?
I can't help you fix that.
This is why I hate doing thermal modeling, just sitting here all day. I'm just kidding. Oh man, I can't even. Okay, you get the point, right? Like everyone's on board with me.
We're only doing this because we've got the next sheet that already has most of this put in, but we wanted to make sure you guys could see what the actual input.
I can't even find the swing door at this point. Oh, there we go. Side hinge, single door. There we go. So it's like starting to build it in there.
Yeah.
Then if I.
Thank you for your sacrifice.
Yeah, thank you. That was rough. Going to this. So then I just start exactly taking from whether it's your window schedule or you give me a list, I use the drawings. I literally just put in every single window and assigned it its number for the quantity and then the window type. And I wrote in your CPD values for verification that that is the window type. And this spit out this average, like I said, that is only based on this size. This is the old path B version of doing it. We're saying, hey, I'm using the label sides only. And then it automatically, oh no, not automatically. I had to import, sorry. Oop, back here. I came in here and I put in the center of glass values.
Yeah, the center of glass values, either I'm going to ask my IG manufacturer to provide that, or it's going to come from NFRC.
I generated off here. And so I have those. And then these yellow ones here, this was based, these numbers right here on the, I guess I should use.
For Stefan's
for Stefan.
benefit, that can be automated. That doesn't need to come from the manufacturer.
But currently what we did was we just took the values from here. If you're going to look down here from this, I took a screenshot of it and I just imported the value for those windows based on the glass that was used. Then I put in the glass values and it automatically generated the site specific size.
And we've talked a lot about the idea of taking that CPD number and being able to just scrape the data directly in, so you're not putting that in. But yeah, I think there's ways for us to make the calculator even faster than where it is.
Yeah, absolutely.
A testing number, or that's
It's CPD means Certified Product Directory.
okay.
So it is the certified number.
Okay.
Yeah.
Which comes from like also their models or
NFRC.
NFRC.
So if you go to
Yes.
NFRC's website for certified products, you can look up the CPD.
Right, and yeah, whatever. How they come up with the numbers? So it's physical testing. Like you send those to NFRC to test it, and then that's a number.
It's an NFRC supplied code for that particular product type, raising type, and model size.
Yes,
Yeah.
and for
So it's just a number that they apply.
and right now it is physical testing.
First, it's simulations approved. Then they select certain models, or you select certain models to be physically tested. If it matches, then they'll create a CPD for it. So it is validated by NFRC. And you know, we had created, you know, your report, which I won't give all the data for. If it pulls up here, and if I can switch back and forth, like we are right on the money. 1.422.
1.42.
Yeah.
Yep.
So, let me go back in here. And I just recently, just over the last week here, I also wanted to try it on an aluminum project and try it out. Unfortunately, I don't have the comparison yet ready to show you, but I know that the numbers is accurate. What I want to show, meaning the one that I have modeled, I just don't have the deliver board. But I also, not a certified product, but I modeled it as if it was. And I wanted to show that there was a discrepancy that actually would have favored had I just modeled this. And the reason why I go up is I have a lot of small vision areas in this particular window wall. which really hurts that final number. But my physical or my actual modeling this with brute force, I'll call it, the old path C, I am off by 0.8% in total values. So, and that took me 45 minutes. So yeah, 0.8% is my discrepancy. Yeah, between what I've modeled by like really modeling it. I mean, I had to really model because it's not a CPD. But when I put it in as if it was, I'm so close to being accurate to the calculator that I'm just like, whew. And it just shows that, you know, I get it. Averaging just your label, not guaranteed to work. But once you put it through the calculator, it's running a linear calculation and it works. So
yeah, so it's less than 1%.
Yeah. Oh, sorry. This was just this calls back to VVBL. So the report that I had issued for you back when we were doing it, and I do a lot for people who don't have NFRC labeling, is there are requirements that still exist. So in essence, we want to provide the tool so that it can assist at all levels throughout the construction phase, but that if you can't follow that, this path still exists. And this is just an example of one of our reports. You know, I'm still putting all the same relevant information in. It's just I can't use the calculator because it isn't certified. And I obviously want more certified products so I can prove the calculator without also having to do the models. But that's it from us, really.
Yeah, so go back to the question a bit earlier, and you don't need to go to the slide.
Okay.
Let's leave it here. But
This conversation about accuracy is obviously the big, like, well, how are we going to get there? And we've gone round and round on it. I think the place that we still have left is to, like what Jomo said, we have to continue to validate these models, keep running them through. Personally, for like a quality control standpoint, if we get to about 35 of the specific models that we're looking
for, threshold for things like that, I think there's a level of documentation that's needed for us to just be like, hey, by the way, this is about 35 projects of this style that we've done. Here's the things that we found that were outside of that. I personally think once we provided a paper that essentially shows, you know, here's the contrast between these 35 projects or so, I'd be willing to stand on a pedestal and say, all right, I think this is about as good as we could possibly ask for. But this room is filled with a fair bit of engineers. What do you guys think? Where is accuracy enough for this conversation?
Oh, wow, everybody's looking at me. When it's enough, when the customer, enough for the customer to accept, that's when it's good enough, right?
But I think you guys are there, like, it's like the whole point of this tool is for energy model to use and know that at the end of the day, an energy model is still a model. It's not 100% accurate either. And so like there's checks built into the energy models. Like your modeled floor area has to be within 5% of the gross floor area. So like there's a 5% per floor area when giving the same thing for windows. You guys are clearly within 5%. So I say it's good enough.
Right.
As an energy modeler, this is way better than what we've been doing already. So why not? Yeah.
That's a great
for all energy.
I've been so it's I think that
once we get to a place that we're comfortable is running it through Casey and a couple of the groups that we have that are dealing with energy modeling, it's like, you know, how close is close enough for you guys? Like I said, I think if we bring back a case study on here's the handful of projects that we've run, here's what their differences look like. I agree. I think we're there essentially. I think this smaller operable or like the smaller combinations, kind of the one thing that we've run into. And frankly, I think we deal with it fairly well once we've plugged in the separate model. Yeah. So that's a little bit of best practice too, that we'll have to be considerate of with the calculator, is explaining, you know, here's how the calculator works. But
90% of your products have a CPD and 10% don't. Were you just talking about kind of buying them?
So there's definitely a way, but you're really getting into how you deal with path.
Product still has to be simulated to NFRC. There's no way around NFRC in Canada. You have to do it in one way or another. Like, hard stop. There is not another path.
Yes.
Unless you're using the
But-
PHPP model.
Then you're using European models, and that's
Whole other end.
but that's and I
that's
don't know how
entirely
that survives harmony.
Like, frankly, that has, I don't, anyway, that's speculation, but I think that has to die eventually. There's just no way to deal with it unless we start including PHPP as part of our thinking on modeling. That's all.
I'll be honest,
Worms.
I had
Like, just to tell you guys, I had 2 staff who were certified passive consultants. One was design and one was consultant. I can't even tell you what the difference is. And I saved one project. The concept was I want passive house windows as a component, but I'm not going to do passive house certification on my building. Like, I'm not, the model is not, but I want to sell passive house windows. I was like, then you're doing it wrong, because your whole assembly, your whole building is passive house. So I'll do your NFRC model for you all you want. And our
Yeah, but it doesn't make much sense if you're not going to certify.
no,
Yeah,
no.
you know, there's different opinions on this. And I know, I mean, as Innotech, we care a lot about where Passive House is going and what we see in it. But frankly, it's a stepping stone from my point of view. Like, as Adrian Edge, not necessarily Innotech, but there's still room for the industry to grow. And so these are the kind of things that help us get there. I think unquestionably, and we do need pushes like that, because otherwise we're going to get pretty complacent on spinning in the same spot. But
So talking about incoming product from
Sure, I'm just thinking about this process and whether you're certified or not, and I mean, that whole question is a big debate unto itself. But this sounds like this opens up an even easier path for an offshore product, because now you could say, okay, what's your systems? Model 3 of those, because it's a picture window at 4 feet by 5 feet, it's a casement at this, it's an awning at this, and then plug that into the calculator and get all of these numbers for all these configurations, instead of now what we do today, path C, fully modeling because there's no certification behind it. Is that a path that could open up here, making it easier for offshore non-certified products to have a path in?
so this is, I feel like we've been in the midst of this conversation for the last 6 months to a year on part 5 and where that sits in this conversation. Because harmonization, if we're talking to Robert out in Quebec, he'll tell you that harmonization means part 5 has to die here. And in BC, we're gonna, I think, be up against the wall on that topic, and we're either gonna push back and the national government's gonna shift its gears, and we're gonna look at part 5 as a real opportunity for this, or we're gonna have to backtrack, and we're gonna have to essentially deal with this, and there has to be a certified product. There has to be a temporary label. There's just no other way around it. So if that's the case, then no, it doesn't make it easier for importers. I think we still wind up with the same problem, because they have to go through the certification. They have to provide the CPD information. If it's part 5, you're right. Like, if we stick to that goal, then we potentially sacrifice that being a gate. But give and take, we've got push and pull on that subject. I think that's going to be hard.
I will say that we can, like, we're working with an exposed Excel spreadsheet, hence it's not being made available. When it's actually released as of the calculator the public can reach and get to, I think one of the fields is input your CPD number.
Yeah.
And if you put in a fake CPD number, it takes, all of about 20 minutes to double check that on site.
Oh, we were even talking about it earlier. You could.
Yeah.
automate that for manufacturing.
Sure.
You could pull up your list of active CPD numbers that would go and get that information.
Or the output to make sure you've got the manufacturer's name right.
Yeah.
Like
So we're looking at ways to.
So if we
to
put out
streamline it.
this calculator,
Putting in the CPD number, no, it doesn't make it easier, because they can't do it unless they put in the CPD number.
And the other option is, because my experience with European product, and like we have a lot that comes through our door, is NFRC catches them off guard, and just the values that it's generating in contrast to the European values, that like pretty much universally, the instinct is like, that's wrong. I'm just going to give my European values, at least the first crack at it is like, no, these are the best, these are the best. And the unfortunate reality is we actually allowed time, and I don't mean this to be rude, but we allowed time for architects to be like, I like European windows. Not just because they look nice, they have better hardware, but because they give better numbers. We were at the event out east where he's like, I couldn't find a manufacturer that could give me the numbers I wanted.
Yeah.
For in Canada that they could get from Europe. And it was like, actually, you did find the same comparable product. You just didn't know.
For reference, we're talking about a group called the Ottawa Housing Society, who was tasked by the federal government to deal with deep energy retrofits out that way. And so they had a handful that they said, we frankly just had no windows locally that could serve our needs. In Canada, we just had no one. And so they imported windows from Ireland. And it was rough.
And I
think they had a heck of a time with it.
If I modeled them, you'd get super similar to what we have readily available here. So I think it can create an issue, but the mindset is not, okay, now let's fudge NFRC numbers, because you're really setting the expectation in your communicating, and what your deliverable is like, you're kind of setting the baseline of what to look for. So if someone delivers a product that's giving really wacky numbers, it's like, oh, how on earth did you pull this off, right? Like, that's kind of the thought. I also think there should be whether it's a tool 2.0, where there is a mix. Maybe you have a brand new product and it's not NFRC certified. That's probably the next thing to look at, where we could say, hey, you're going to have to do a full report like the one I showed, but we'll do everything we can with the labeled product, and anything we can't, we're doing this. But this is just, you need third-party verification, you need a stamped, report or whatever. It is only for this project, because what I feel that the cities get frustrated with, the inspectors, the people are relying on to make sure that is what it is. They just get paperwork overload that eventually just give up and say, fine, whatever, it's a good window, I don't care.
Yeah.
Yeah.
Well,
yeah.
and so that gets to an interesting point, which is how we deal with it as Fenestration Canada, and versus how the industry is going to deal with it. Like we could put our position essentially, like we were talking about, like you have to have a CPD number in order to get your outputs. And then if you need to go a different route, hire a modeler. Like, it's like you have something either too complex or too early on that we should be using this calculator to go deal with. But I don't know, but it's worth the question.
Yeah.
I don't think today I've got an answer for it. I don't think any of us really have an answer for it.
I think the city and province
Need to
They need to
lay down the rules of what they're going to do, what they're going to allow. I mean, if we're obviously going to come back with them once we're ready to go and say, here's what we've got, here's how it works. Assumably, they're going to adopt it because they're looking for a solution. But at the same time, we need to be saying, okay, this works for NFRC model products or CSA model products only. What are you going to do about other products that aren't certified through these programs?
Currently, your code
They need to
is
answer
giving
that.
Opportunity for products that are not modeled. How do you want that handled?
Yeah.
Like we're saying as an industry, theoretically, that we
By the rules, this is for them.
Yeah, and the intent isn't to stop offshore product.
No.
The intent
Just to have them playing in the same field.
Exactly.
That's all. As
And
long
we've
as they're
already
doing the
created a
same
document
program.
in Canada on importing products and what's
Yes.
required.
Yeah,
So like,
absolutely.
it's easy for us to provide additional support so we can help people get over that
Yeah.
that threshold, because
For
we
sure.
want people playing.
So
Playing outside of it, we're not apples to apples anymore.
So with regard.
I just wanted to ask.
Sorry, no, hand up first. Sorry,
Someone
who's waiting?
Because there are some issues when you just go with CPD number, I'm not seeing some errors when you have like reinforced on, or we have different configurations. As you thought. Maybe it's better we just go with CPD. Compare the result with the spec. And when spec like we call for 1.8 and we are 1.6. So we know we are different.
But if spec just called for 1.8 and you have 1.79, you're really close. So people with side specific.
Well, the challenge is, I give you our last one. What if the requirement? Just CPD, I have 1.33. When I run it through calculation and I model it, I have 1.53. Yeah.
So the calculator is more accurate.
Yeah.
Is essentially what we're saying. But
So that is the difficulty in this conversation, is that
held to account to get to accuracy, and we know that that is less accurate. How can I possibly use it?
Yeah. Because the certified values are saying it passes at 1.4, just theoretically out there. I run it, it doesn't work. So and already the City of Vancouver modeling guideline is saying size specific, energy models want size specific. So I don't think we're gonna muscle our way into CPD only. So, yep.
I just checked out CPDs online, and I haven't seen each entries with specifying what spacers they have, and you guys know spacers can badly grow on the U numbers, overall U numbers. So am I just missing it, or all of them are just having a?
In Innotech, we have 2 different spacer bars that we're using for our products, and I have to model.
Like,
And it's and the name is specific to that spacer bar.
I see. Yeah. So if you have a product, a specific project that doesn't have that spacer, then you have to model from,
Right.
Or take the third-party as well.
If I'm not providing, so if I'm providing the wrong CPD number for the product, then so talking about gaming the system, to Manny's point, that'd be one way to game the system. Essentially, I've got the same low coding, and it's like my language in the CPD is kind of obscure and it's hard to know. That is definitely a work in progress. But we have to model it. Yeah, we have to provide that modeling. So it is an opportunity for somebody to come back and like, okay, give me what the nomenclature is for this particular space part. That could be cool. But teaching the industry how to ask that question, kind of critical. And I think either one, because I don't know who was first.
Oh, I was just, in your calculator, you're talking about reinforcement and other conditions. Is there a way to sort of, in the calculator say, I got so many linear feet of reinforcement?
That's version 3.
Yeah.
And then it'll affect it, the calculator will just up it for that condition.
Yes.
For that, for that, and it'll just increase it by 10%.
That's how
There's a correlation.
yes. The is to make it a linear calculation, which actually follows what NFRC has done with their new certification program, LEAF. That is way too long to get into, but it essentially splits up like the question on the spacer bar. Those are 2 different trend lines. Oh, reinforcement in both of them. That's now 4 trend lines. Like it's to all these linear things. And I think that is what we're getting to is, can we do enough research that we find out, hey, reinforcement does play a role. What is the linear number we can assign per square footage? Or it doesn't play a significant role. We're going to leave it alone. In my conversations with NFRC, they've said, yeah, we know we can, we were concerned they have a hinged, it's like a hinge casement and a picture window. I don't remember what they call it, but they modeled that as an actual certifiable program or a window. But they have other configurations that they totally eliminated because, hey, when we combine it all, it actually doesn't make that big of a difference. So that's determining that amount that we have to care about.
A value by NFRC that's been tested. Yeah. But an alternate value is been modeled.
Yes.
To NFRC, right? It's like you may not have a value listed on a website, but your products have been NFRC or your assemblies.
Yeah. that you've gone
You've
through?
actually gone through, and I think when we talk about overseas products, and it's like, what we really want to do is make sure the overseas manufacturers and suppliers have put all the R&D for North American products, like the North American, we've all invested, or North America have invested significantly in developing their systems along with NFRC guidelines. And it's not a fair playing field when they come in with alternate values, giving them to clients,
Absolutely.
but they haven't spent the 30, 50 grand over the last 10 decades in the research and development of their systems in trying to meet high performance systems. They're high performance.
Absolutely.
Right.
Part of the other challenge with that is the values that they are marketing are a U value. And architects going, well, your U value is this and theirs is this. It must be the same thing. It's a U value, but it's not, because of how their processes and how they model and the values they use to model. So that's the bigger issue in a lot of manufacturers' sort of viewpoint. I'm fighting a battle trying to make the architect understand that my product performs thermally as well, but they're two different values. He's saying, no, this guy's better. Well, no, he's not. No, he isn't. They're using a different process.
We just need to change.
That's a challenge. So yeah, getting everybody on the same field. That's what we're talking about.
Just get the NFRC to change their boundary conditions.
Yeah, sure, they'll do that.
Especially about
Yeah, absolutely.
Ultimately, it comes down to the consultants, architects, owners to accept that product.
Yeah.
Without the checks and balances that they make in North American manufacturing goes, oh, your product doesn't make it, but I got some value over here. And I'm not going to do this due diligence, and I'm going to submit that.
That's a U value. What's going on? It's a U value. It must be the same.
For instance, on this, so we have like thermal letters and thermal reports that we do. Thermal reports are obviously more extensive. When I have jobs that they've all done, all their certification, I usually issue a letter. Basically average everything out, we check everything, and it's generally fine. But what has become as a result of the implementation of, well, a line in the BC 2018, to be all honest about it, is all of a sudden it's like, no, I want that modeled. So it's actually pushed people back who have done the work, spent all the money to play in the same field. Because if I have a person who's brought a product from overseas, every single job until they decide to pursue certification, I'm doing this. And it's like specific to that job. There's the legal address, the city address, the project name. And like, every once in a while we'll have a municipality be like, can you guys take a quick look at this? I'm not really sure. And I'll see, some version of ours like, no, like that's been taken out of bounds. That's been mitigated, I think, over the years of people understanding that if you're importing stuff, you need to have this. So I think there is a path that if we wanted to keep Part 5, or if that was a necessary thing, that people could still do it, but it is a cost on every single project. Whereas I think this is trying to enable and empower to either have no cost or very limited. Like you need third-party verification. Okay, oh yeah, that looks good. Here you go. Like I want to bring back the letter essentially for the people who've done their work. So, yeah.
In which you have models.
Some of them, yeah.
In models, if you're writing a letter on something,
yeah,
right, you have a model that product. I mean, NFRC modeling is to size.
Yeah.
Project specific sizes, NFRC modeling to that size.
Yeah, correct.
Right. But in your model, in your program, once you have your therm file, you're changing the size, you're assessing the space you're part of the class size, you're checking. There's a process, but it comes back to you got to create a model of that assembly. Okay. Right.
Comment with regards to having like a link to a database that checks and validates your CPD number. Just be aware that your CPD numbers will change every time that you get recertified.
Yeah.
And the moment that recertification goes through, it's a new number, and the old data is not available on the database.
Right.
So we run into this right now when somebody buys Windows and then they apply for the rebate down the road, and in between CPD numbers has changed, right?
Yeah.
But I think you need to maybe build in a little bit of flexibility if there is going to be that kind of a thing where maybe so that it doesn't become very confusing for the user.
Yeah.
Because they get the number that's on the quotation. The quotation was from 6 months ago.
Yeah, right.
Right?
Yeah.
So that there should be some maybe
Yeah.
retain historic data for a period of time and validate against both the currently posted data and the historic data.
Yeah.
I mean, kind of.
Yes.
We're gonna use a CPD value that is no longer certified. That's a bit of a slippery slope too, right?
It's funny you bring that up, because actually I was checking your model for this morning. And I had updated my HEDV and the glass had changed just slightly. I was like, oh my gosh.
Yeah.
Yeah.
Well, and in that case, my responsibility, I think, as a manufacturer, is to give you the proper CPD number for what's there now.
NFRC database, bit of a challenge.
That's a great question.
Yeah. Yeah. Or we, update it once a month or something like that.
We talk about accuracy. It's like, okay, City of Vancouver 1.4 requirement for evaluations. Why can't it be 1.4 plus or minus 10% or 1.35 to 1.45? Why is it 1.4? Because we all know that 1.4 really isn't 1.4, just because of how the perimeter is sealed, so there is inaccuracies throughout the whole process. Even the modeling has a plus or minus.
Yeah.
So why don't they create even more flexibility in actually the number that comes out of it?
So when they do the physical validation, what is the plus or minus that's allowed? On the guarded hot box testing.
I thought it was 5, but I'm not sure.
So you've got a certain amount of error that is built into the system itself, right? Or so,
but that question's going to solve itself here over the next building code cycle, because eventually prescriptive numbers are going to disappear and it's going to be all performance. So a 1.4 won't be there anymore. It'll be model the building, get to your Teddy numbers and your NUI numbers, et cetera, et cetera. So whatever product gets you there, that'll be the U value of the product. It doesn't need to be a 1.4. Be anything. And we've seen that with the step code already, where I had sales guys would come in and say, oh, it's a step 3 build. What's my U value? So I don't know. It could be anywhere from 0.9 to 1.6.
It's whatever the project specific.
Exactly.
Yeah.
Right? And that's where we're going. That's what building code state is, right?
6 inches on the outside of the word.
Exactly. Yeah, it can all change. There is no number when you get there. Right?
Manny, you kind of nail something.
We're talking about very specific numbers, and we get into this weird world of like, there's no compromise on where that number is. And even like solar heat gain, I'm really bugged by the no one can tell me which one they want in what direction. Like, you need a 0.3. It's like, okay, better than 0.3 or worse than 0.3, and what's worse and better. And so you get
like who's the responsibility? I mean, you're thinking you got the architect. You got the city officials and whatever. It says, okay, we're 1.39. We need 1.4. We're 1.41. 1.39.
I had that
Okay,
conversation
accept it.
with DC Housing.
Like somebody else. It's somebody else's fault.
What does your specification need to be? Because they were asking, like, okay, what's the value we need to put into this?
like, well, you should put a variance here. Like, give me the spectrum that's okay within your model. But that's not being done right now. That's not a typical practice. What we get is the one number in the specification, and we
part of the conversation.
Yeah, I agree.
Yeah, I'd agree. I think one thing that we're trying to look at this from, I think Adrian and I are pretty united on this. It's like, do we design this calculator to solve 100% of the problems? Or do we look at how many 85% of the projects can we just deal with,
take care of right
and
now.
be done?
Yeah.
And then be like, okay, I got a headache here. Whoever my energy modeler is, can you sell me? And then version 2, version 3, or whatever.
Or even, again, going back to, there needs to be professionals in the room to deal with the other 15% of this. The energy modelers shouldn't go away.
No.
if we get into really hyper specific performing buildings, we're going to need those professionals in the room. We're never going to solve it with a calculator like this. We're going to need people that say, okay, this building shape is like this. This particular environment situation is like this. And because of these like competing factors, we know the building's going to perform like this. This is just a resource, a support for them.
Yeah.
We're not going to solve those specific situations, and we shouldn't. We should have professionals there.
Well, the calculator is not meant to certify. It's meant as an education tool across the board, from designers, builders, consultants, to get on the same page as to, we need this to kind of meet that target.
Yeah.
So it sounds like what everybody wants most from energy modelers would be like, this is our target U value, so that we have a little bit of wiggle room in our energy compliance. This is the absolute worst number that your windows can do and still meet compliance.
Here's best worst case scenario. Here's be like,
yeah.
I've got my model right now.
Yeah.
And if you can give me something that fits in this category,
Yeah.
then we're good.
Yeah, this is what we want, but this is how bad. Bad.
Yeah, and I don't know. So for manufacturers, yes, I want that.
That's what you want.
I really want that. Like
That's
that
good to
makes
know, and I
everyone.
can go to energy model people and say that.
But the challenge that we are seeing as industry is they look them as like independent dials, like U factor and solar heating. Like I was at a presentation where they were all excited to show their model and how you could use Windows now, the code changed and all that stuff, but they had pinned solar heat gain at 0.35. Now the U factor was all over the place. And I'm like, okay, well, that window doesn't exist. Like you've created a window that nobody has, and you're really excited to get everyone on board. And you've spent all this energy, effort, work. You can specify this all you want, and you're going to be sorry. So I feel like you, to a point, Manny, like who's the one taking responsibility? The thing that I like about using data that is already third-party validated is it kind of sets the standard. Like we're now on an educational platform. We're saying this is what you can get. Like build your models to this rather than give me those windows and you just scratching your head is where to go.
Yeah.
And that doesn't mean you can't change. I mean, yeah, maybe sometimes you have to get really creative with your frame or window, but use your product.
You might need to be looking at the industry and asking window and door manufacturers like, okay, we've got this particular type, and what I need is for you to come up with something new.
Yeah.
Like, yeah, we could get that, but if we're really, that's not what this deals with.
Yeah.
Yeah, like this kind of tool, and again, probably 85% of the industry doesn't need that.
Yeah.
99% of the industry probably doesn't need that. We don't need to get into the 1% conversation.
Like, get this whole U value discussion.
Oh
Getting
boy,
targets.
so aggressively.
Right? Like, this is blow
There it
everything out of the
is.
water. It's like a non-thermally, well, I should say non.
Think about what
But-
the effect of vacuum insulated glass would be if we could increase the scale of how much vacuum insulated glass is on that frame in combination with the frame value. Like if the frame value is so much worse than the vacuum,
then this becomes wildly critical, because otherwise you're not going to have any idea how those windows are actually performing.
they do, but if your glazing space is so much bigger.
I got it. Vacuum frames.
Oh, there you go.
Yeah.
Vacuum frames.
Dyson's in. He is
Yeah.
turning on when you walk inside.
Vacuum cladding. Like, think about a vacuum facade.
There you
go.
I would never take you as a marketer.
Right? Like, I mean,
Are we running out of silicone? Like, we're gonna be whistling the whole city.
Yeah. So, I think we're pretty much at the wrap up of this.
Outstanding questions.
Or feedback.
Or feedback. Yeah, feedback's great.
It honestly is. Yeah, we need manufacturers to give us projects with that they have the certification already done. That is honestly it. That's the biggest obstacle to get that amount of room. And then, I mean, some of it's more R&D and going down that route, but yeah.
I just wanted to offer kudos to what appears to be a great tool, and
serves a genuine need. I think you guys are on the right track and your accuracy is well within what the industry appears to need. I think the ability to clean the calculator is probably minimized. I've tried to think through how, if I was forced to come up with ways how I do it, and I have not come up with anything consequential in my head. Could you put in a rough opening compared to a window size and make a difference? So yeah, good job.
Thanks.
Thank you.
It's been a great collaboration working on all of this. We've got a great group that is doing it. We have buy-in from the province and the city. They're just saying, yeah, you can get that close. Let's go. So next steps are going to be some more trials, tweaking of it. Then once we get a tool that everybody's satisfied with, then we're going to work on hosting that on our website, have an interface, come up with ways to automate the input of CPDs, et cetera. So wild ass guess, 6 months.
Yeah, that's kind of.
So if you do host it on our website, any potential legal liabilities there, how can we address them if there are?
It's
Well, it's a disclaimer.
Yeah,
We'll have a disclaimer, there, right? But I mean, no different than today. If you have an NFRC value, it says right on the bottom of it, this is applicable only to standard model sizes. So no difference, really.
It's not meant to certify.
No,
Not
yeah.
certified.
No, honestly, I look at it as for like 3 things. It's an education tool. It's a fast for that. And it's also a marketing tool in the sense that this is what's expected in Canada. You're bringing your product in Canada, you're building your product in Canada. This is the expectation. So, yeah. Okay. Thanks, everybody.